now I'm going to calculate the slopes of segments PL, LA, AY, and PY using the slope formula m is equal to y2 minus y1 over x2 minus x1. So just straightforward use of the formula. In this case, 7 minus 2 is on the top, 11 minus 3 is in the denominator, and so my slope in this case is going to be 5 over 8. So for LA, I'm going to take 7 minus 5, put that in the top, and then 11 minus 6, put that in the bottom. I get a slope of 2 over negative 5. Now for the slope of AY, I'm going to take just 5 minus 10 and 16 minus 8. Now notice it didn't matter if I took 10 minus 5 and then 8 minus 16 or 16 minus 8 or 5 minus 10. It doesn't matter which order it is as long as it's consistent. If you look at this, the point would be 16, 5. There's the point 16, 5. Here's the point 8, 10. There's the point 8, 10. So we can see the consistency kind of built into this. So 5 minus 10 is a negative 5. 16 minus 8 is an 8. So this is negative 5, 8. And lastly, PY. So I need the slope of PY. P is 3, 2. Y is 8, 10. So I'm going to take the Y's 10 minus 2. And then 8 minus 3. I'll get 8 over 5. So that's 8 over 5. So I have 5 over 8. 5 over 8. 5 over 8. Or 5 over 8, 8 over 5, negative 5 over 8. This one I want to take a look at one last time. Nope, looks good. Got 2 over 5. So everything looks good in this case. No, it doesn't. This is a 15. I knew there was something wrong. That's a 15. So it should be 7 minus 15. So that should be 8 over 5. Now, this is actually a really good learning experience because if you notice, you have a 5 and an 8 here, a 5 and an 8 here, a 5 and an 8 here, a 5 and an 8 here. And if we go back up to the distances that we found, we always found a 5 squared and an 8 squared. 5 squared and an 8 squared, 5 squared and an 8 squared, 5 squared and an 8 squared. These values are connected to each other. They are all connected to each other. So which is why when I saw 2/5 there, I knew something wasn't right because my change in x and my change in y is used not only in slope, but it's also used for the distance formula. So being able to take a look at that error and say, hey, I made a goof, and then go back and kind of analyze what it was, and it was right here, it was right there. It's probably because I was trying to do this video way too fast. But that's a good thing to see, that you have to be careful that you're using the correct points. And then the connection between slope and the distance formula is you're using the same values, because that's y2 minus y1. This is y2 minus y1. That's x2 minus x1. That's x2 minus x1. So we're using the exact same things. So be careful with that. Make adjustments if you see that you're not getting what you think you should get. And the nice thing is, once you are able to do this, you can do this. Once you're able to do this, you can do this. And it all works out nice for you.